chance to talk with Tim Peake about some of the exciting things that are going along in space. Hi, Tim.
Hello, good morning, and good morning to everybody who's joining us today for this fantastic discussion we're about to have about rocket science.
So for the last couple of weeks, we've been talking a lot about isolation and confinement and so on, obviously. But this week, we wanted to focus on one really exciting project that Tim helped us with, and that's called rocket science. This was a huge experiment. It was intended to grow food from seeds that have been in space, and maybe you or perhaps your school took part in it. Tim, have you ever eaten any food grown from seeds in space?
Well, yes, we actually ate some petals from the zinnia plant that Scott Kelly was growing. He was up there for a year, and he was really enjoying, trying to get these zinnias to grow. And once he harvested them, we were actually able to eat a few of the petals. They're actually quite bitter tasting, but when they're mixed in with plenty of other salad and a nice salad dressing, it's fine. But just by themselves, you wouldn't want to eat too many.
So were they meant to be food, or do you eat the flowers anyway?
Well, I mean, that's what we're going to come on to in the discussion. But they were part of an experiment to see what kind of plants, what kind of vegetables can be grown in space, and it went very successfully. We learned a lot, actually. That at one point, the entire experiment was a disaster, and the zinnias were all dying, and we couldn't work out why. Just trying to get the right nutrients into them and get the right watering schedule, and Scott really kind of took it under his wing and decided to make this a pet project. So he said to Mission Control, "Look, can you just let me for a few days do what I want to, do what I think these plants need when they need watering, and look after them and care for them and nurture them?" And sure enough, he got them to grow spectacularly.
Wow. Well, there's obviously a lot to it, but let's start with the beginning, which is growing seeds. So in the summer of 2016, 600,000 young people became space biologists when they took part in this 35-day experiment to grow and sow and grow rocket seeds that have spent 6 months on board the International Space Station. Now, to help us find out a bit more about this amazing project, we've got two experts with us today. One of them is Alana Karma. She's the schools manager from the Royal Horticultural Society, who, as you know, are running the Chelsea Flower Show virtually, at least this week. Anyway, she was part of the team that led the activities of the schools. Hi, Alana.
Hi, morning.
Nice to see you. And we've also got Dr. Jake Chandler from the Royal Holloway, University of London, who's been part of the team of scientists who've just published their results because they've done some science experiments that were similar to those from the kids. Hi, Jake.
Hi, good morning.
Morning, Jake.
So, Tim, you started all this. When you were allocated to your mission, you came to us and said that you'd like to make sure that all young people across the UK got to be part of it. Why did you want to do that?
Yeah, a number of reasons, really. I mean, primarily because the mission was such a valuable opportunity to get everybody involved in some way, shape, or form, and particularly to get young people involved in the mission. It's 29 years today, actually, that Helen Sharman last launched to the Mir space station. So we'd waited a long time in the UK before having another British mission. So it was a great opportunity. And, I spoke to you, Jeremy, and the UK Space Agency, and we came up with this big project, about 30 different programs, all centering around some form of education outreach, but also reflecting the kind of things that we're doing on board the space station, whether it's Earth observation using Raspberry Pi computers to take photographs, or whether we're looking at space diaries, or whether we're doing things like rocket science. And that also incorporated some of the biology experiments that we're doing in space, and looking at growing plants and vegetables. So it seemed to be a brilliant project to get involved in, and hopefully to embrace a number of schools around the country, not just one or two, but really reach out to a whole host of different people and get them on board and get them involved.
Great. So, Jake, we're going to come back to you in a moment. So I'll ask Alana some questions first. So, Alana, can you talk a little bit about how the project worked? What did you do to set up such an enormous project?
Yeah, it was quite a feat. We put a call out to all schools and groups in the UK that we work with via the Campaign for School Gardening, and invited them to sign up. And we had a huge launch event at Chelsea Flower Show, which you can see in that picture there. So we had a huge stand which was brilliant. We had a Mars rover, which you can see there, which was really cool. And that was really to raise awareness to the general public of what we were aiming to do. We invited all the schools to sign up with the view that they would receive some rocket seeds that had been in space with Tim, and then some rocket seeds that had remained on Earth. And their challenge was to grow them and measure how they grew.
Can I ask you why you chose rocket? Now, I've just thought people might need to be reminded of what a rocket plant looks like. This is one from the greenhouse. Very tasty, but it's just a rather boring looking plain green plant. But why rocket?
Yeah, there are a few reasons. The first reason was the weight. So we were able to take 2 kilograms of seed up because, as well, you know, it's quite expensive to send things up to space, and the space is limited. So we wanted a small seed that would fill enough of the space so that a lot of schools could take part. We wanted to make sure this was very far reaching. Rocket seeds are very tiny, so that worked really well. Obviously the name is perfect, rocket. We wanted something that would fit quite nicely. And also rocket's very quick to grow. So we wanted something that would give results quite quickly for the schools because it was quite exciting. So we want to see something that would take on quite quickly. And the last reason, I think, well, Tim would be able to tell you, I think in space, your taste buds can dull a bit. So things like rocket, which is quite peppery tasting, would be something that would be ideal for astronauts to grow in the future.
That's a good point, yeah. Now, you had, how much did you say, 2 kilograms of rocket seeds to launch? So they were launched on, what was the launch that they went up on?
Oh, it was in 2015. I think it was August sort of time that they were due to go up. And the original ones were due to go up on a SpaceX rocket, which exploded. So the first lot of seeds, unfortunately, we lost. It was an unmanned rocket, but yes, unfortunately.
Wow. Presumably you were aware of this at the time. We're now expecting SpaceX to provide manned missions. Did you look at that with some concern, thinking maybe one day this will be me?
Yeah, well, this was just 6 months before our launch, and so we'd had a number of things go wrong. Actually, we'd had an orbital spacecraft that had been destroyed on the launch pad. We'd had a Progress resupply vehicle that had gone into orbit, but then went out of control, tumbled, and burnt up in the atmosphere before making it to the space station. And we had this SpaceX that blew up a couple of minutes into its launch sequence. And not only were the rocket seeds on there, but my spacesuit was on there as well, which was the one that I needed to do a spacewalk. So I was wondering if I was ever going to get the chance to do a spacewalk because of that, along with obviously a host of other different bits of equipment. But you know, it's getting to space is hard work, and it's a challenge. At the time, SpaceX was still learning new things about the launch, and actually since that event, they've been able to really make their vehicles much more robust, much safer because of it. But yes, of course, you know, when you see these things blowing up in the sky and you think that's a future crewed vehicle, then you are concerned. I'll just point out, actually, in just 10 days time, we do have the first crewed launch of SpaceX. So Bob Behnken and Doug Hurley are going to be the 2 NASA astronauts who will be riding that rocket to the International Space Station.
Goodness, that's an event to watch out for. We've got some really good questions coming in, as well as ones that have been submitted previously through the campaign for school gardening. Rory Byrne wants to know how many seeds there are in 2 kilograms of rocket.
I wondered if that was going to come up, and I think it was around 1 million seeds. I remember it being around that kind of figure.
That's what I too, yeah.
Yeah, so a lot
of seeds
flying over Florida.
Exactly, yes. So I wonder if they had a crop on the beaches of Florida that year. That'd be strange. So the second batch then was launched. I trust that was all, plain sailing then.
We had a few issues. So the first batch blew up. The second batch, the seeds come in quite, well, these sort of foil pouches that have quite sharp corners, and they needed to be rounded off to make sure they weren't of harm to anyone when they get up there. And unfortunately, someone cut the corners a bit too tight, so the seeds were pouring out the bag, so they couldn't go up. And then the next batch, because the seeds were due to go up in a manned rocket the next time, they had to be boiled at 100 degrees to make sure they didn't let off any harmful gases to the astronauts. So obviously those weren't going to be viable because they wouldn't grow if they'd been boiled at that temperature. So we had a fourth batch that finally made it up to the space station.
God, that's a lot of kilograms of seed. Think how few you get in a packet from the shops normally. So finally they got on board. I presume that was it then. You were able to get on with the next stage, or was there more problems arose?
We did later find out that the seeds got lost on the ISS. Tim was not looking after them as closely as he should have been. I think we were due to have a photo shoot with Tim and the seeds, and they couldn't find them for a while.
So, Tim, how on earth can you lose, 2 kilograms of seeds on the space station?
Well, yeah, because I mean, these have been unloaded and unpacked by a different crew. I should point out, when a cargo vehicle arrives in the space station, there's 3.5 tons. The space station is a busy, packed place. I mean, you're looking at a photograph there on a maintenance day, but there's an awful lot of equipment and kit up there, and it all has to go into specific locations. Occasionally, the wrong bag goes to the wrong place, and then trying to find it amongst all of the cargo on the space station is a nightmare. But we were able to finally, find the rocket seeds and pin them down.
So finally, then, they were there. So what did you do with the seeds? We've got a question from Corinne Ballard from Le Maire de Carteret High School. Where was the seed put in the space station? What did you do with them?
Yeah, so I mean, there's a photo there of me in the cupola taking a shot so you could all see them in space there, these packets. But the cupola is not the right place to store them, because you're going to get a much higher dose of radiation there, and obviously you're exposing them to the thermal variations of 16 orbits a day, so the day-night cycle, illumination, and potentially a lot more damage. So they were stored in the Columbus module, which is just one of our laboratories. So it's a very average type of location. It's about 20 degrees. It's about the same temperature, pressure, and humidity of the room you're probably all sitting in right now. And so that seemed like a good location to store them. In our crew quarters, for example, they'd have been more heavily shielded from radiation, and we didn't necessarily want that either. We wanted a normal average location, so Columbus was the place.
So effectively, we're testing to see whether these things could survive in the conditions they're likely to be exposed to in space if we ever do this in the future. So they spent 6 months in space. Alana, how did we get them back?
So the seeds actually came back with Scott Kelly, who we mentioned earlier. I seem to remember they were shoved under his chair, all packed up. So you can see now in that picture, that's Scott Kelly in that tiny little thing just under the parachute there. So that would have come down and all unpacked. And then they made their merry way across various countries all the way back to the UK, where I think they ended up with you guys at the space agency before they are.
That's not actually Tim. That's we'll fondly call Tim. I think he made an appearance the first week we did one of these Tim Talk Space episodes.
We had a few flat Tims around as well. Yes, and then I met Libby, who's there on the left, over at our seed packers in the the east of England somewhere, and then we got them all packed up, and then they were sent out to our fulfillment house, who then packed them all up and sent them out to just over 8,600 schools and groups across the UK.
So you had to give people 2 different packs of seeds. One of them had been in space and the other one didn't, but they needed to know which was which or not.
So that was kept secret. So Tim helped us by flipping a coin to choose which packet the seeds would go in. So we had a load of red packets and a load of blue packets. So the schools and groups didn't know which ones contained the space seeds, because we didn't want any bias involved. We wanted it to be a blind test. So they had a good time to kind of guess which one they thought was in there. And then we revealed right at the end of the experiment which one was which.
And what were they actually doing during the experiment? What was the experiment?
Yeah, so what we wanted to do, as Tim mentioned earlier, is kind of look at whether it would be viable in the future for astronauts to grow their own food on long-term missions or on the space station. So we wanted to see how well the seeds would grow versus seeds that had remained on Earth. So what they needed to do was sow all the seeds individually. So they had loads of seeds each to sow. I think it's about 100 of each, and very carefully in little individual modules that you can see in the pictures. And then over the course of the 35 days, they needed to measure how tall the plants got, when they first got their true leaves, that kind of thing. And then using randomization as well, they had to pick random samples of plants just to make it really fair, that they would then monitor throughout and see what the difference was in the growth.
So it was a true scientific experiment. Absolutely everything was being done properly. I seem to remember your director of science heavily involved in making sure everything was done properly. I even had one or two arguments with him about exactly how to do it to make sure that we had exhausted all the possibilities.
Yeah, it's very difficult in a school situation or a group, beavers, cubs, scouts, etc., guides. Very difficult to keep it all exactly the same, but we tried to make it as sort of comparative as possible. So recommending how they grow things, what growing mediums / compost to use, that kind of thing, and keeping them on windowsills. So it was the best we could do.
Tim, were you able to follow any of this from space?
I was able to follow some of it. Yeah, I was getting regular updates by email, of course, and actually my crew support team was sending me photographs. And that was one of the best things in space, where you're quite isolated, you're cut off from everything that's going on. So it's wonderful when you actually see the impact of some of the experiments that you're doing, and to see all of these school children taking part, growing these seeds and looking at the results and not knowing, knowing that in their hands is something that's been orbiting the planet, at 25 times the speed of sound for 6 months. And that's a hugely exciting thing, but not knowing which ones were the space flown seeds or not. So it was great to see that reaction coming back.
Yeah, I remember the excitement at the time. Well, before we hear about the results of the school's experiment, let's find out a bit about what professional scientists were getting up to. So let's talk to Jake a little bit about what he was doing more recently, using batches of seeds from the same pack that the kids were doing experiments with. So Jake, what exactly was your experiment? Was it different from the school's one?
It was a bit different, yeah. So rather than relying on the sheer numbers, we actually used very precisely controlled conditions in the seed biology lab. We had incubators that really tightly control the temperature and the light very precisely. And we also looked at the actual very first moment the seed sprouts, or what we call germination, rather than the seedling emergence through the soil, which is what the schools looked at. And then we went further and looked at the molecular level, what space actually did to the seeds.
And so did the school's experiment influence what you did?
Yeah, so I mean, the school's experiment provided kind of the ideas for the hypothesis. So rather than looking at if space affected the seeds, we started to look how space affected the seeds. And the idea was that they were aging faster in space.
Right. We've got a question coming in asking about whether plants, I'm trying to remember whose question it was, about whether roots grow up or down. And I can't know who we are. This is from Rory, who's 11. Do roots grow down in space, or do they just grow everywhere? Do you know the answer to that, Jake?
I'm actually not sure. Maybe it's one you should ask Tim, but I know that they have specially designed containers in space to make plants grow properly. And plants also respond not just to gravity, but to light as well. So if you provide some light, it gives the plants an idea of which way to grow as well.
Uh-huh.
Absolutely, yeah. I mean, in space, one of the really interesting things when you see plants growing is that the roots don't know which way to grow. Because here on Earth, Jake will correct me if I'm pronouncing this wrong, but I think it's a gravitropism, which is the process where roots literally feel the Earth's gravity. And they use auxin transfer as a chemical going up and down the plant, and that tells the root which way to bend. And it bends so that it's going to grow down into the soil, and the light from photosynthesis, the light attracts the leaves, and so the stems will grow up. And so part of the plant's growing up towards the light, part of the plant is growing down towards the gravity vector of Earth. So take away that gravity vector, and the roots just form a ball around the plant. They go in all different directions. So that's a challenge. How do you get water and how do you get nutrients into a root system that's not going to go into any soil? And how can you even, form soil in space? Let me just share with you actually very quickly a screen here. If it works. There we go. So this is, there we go. Let me show you this one first. Hopefully you're seeing that screen there. And that's peas that I was harvesting as part of a Japanese experiment. So you can see the root structure there. They should all be going straight, upwards and growing towards the gravity vector on Earth. But of course, in space, they're all over the place. And we use that kind of bed to pop the peas in so that at least they can get moisture and nutrition. And this is the light that's coming off of our greenhouse in Columbus. At nighttime, it would produce this incredible sort of magenta pink hue because green vegetables and green plants, they reflect a lot of the color green. So they actually use more red and more blue wavelengths. That's the kind of wavelength of light that they need for photosynthesis. So that means that we use this pink light to help aid photosynthesis. And using this method, these are the zinnias that I was talking about earlier, Jeremy, that Scott Kelly was growing. So using that laboratory, we're actually in space able to grow flowers and plants like this. I actually brought one of these zinnia plants down, and I photographed it this morning. That's what my zinnia looks like this morning. So not quite as colourful, but has, flown in space.
Wow. Well, at least you've answered Cole Levy's question about what kind of light did you use to replicate the sun in space. But the trick is you use LEDs, it seems, but entirely avoiding green light because it's a waste. Now, I guess having enabled us to do all this science in space, you must be interested to know the results. So I wondered, Tim, whether you've got any questions for Alana and Jake about the outcomes.
Yes, I'd love to find out. I'm sure everyone else is. And Jake, I know that you've published results recently. But to start with, Alana, the school experiments first then, what were the results that you discovered?
So they were quite varied, but what we did find overall, because so many people took part, it meant that it's quite easy to see them where the differences are. And overall, the schools and groups did find that the seeds that have been to space didn't quite grow as well as the ones that had remained on Earth. But the good news is that they did grow, and that was kind of the point. So that was a bit of a relief.
Yeah, absolutely. And I think the other part of it, correct me if I'm wrong, but was there's the experiment that's going on, but there's also what the children are learning about science and about the whole process. And it seemed to me that was also a big part of what was happening in the schools.
It was brilliant because it was such an exciting topic, space, it's brilliant, and having, this link to your mission as well. But what was brilliant is we were kind of teaching young people how to run a science experiment. So it's kind of science by stealth, which I always enjoy. But equally teaching young people how to grow food, which is also really exciting for us as the Royal Horticultural Society. So again, gardening by stealth. And learning all those skills that both growing and running a science project brings with it. So, yeah.
And Jake, you've published your official report of the experiments, and you mentioned earlier about they'd aged in space. What do you mean by that? And can you tell us a bit more about the results that you found?
Yeah, so we actually confirmed the findings of the school experiment and found that the seeds germinated slower, which is probably why they emerged slower in the school experiments. And when we say aging, we're talking about sort of damage that the seeds pick up. And what we think, for example, is that the radiation, the increased radiation experienced in space, is actually causing damage to molecules important for life, such as DNA and proteins. And what happens if the damage isn't too great is that the seeds are still able to repair this damage, and this just causes a slight delay in the germination. So that's what we think happened.
Oh, fascinating. So the seeds can actually kind of repair themselves.
Yeah, once they're hydrated, yeah.
Okay, and Seth Davey from Lamar Carteret High School was asking about why do the seeds that have been flown in space, why is their growth affected? Anything other than radiation, or do you think that was the primary cause?
Yeah, there could be a number of factors you could hypothesize. One of the other ones that we think is quite credible is the rough journey to and from space. So there's quite a lot of vibration, as you may have experienced, and this probably can cause some physical changes to the seeds. And how this really affects the seeds, we're not exactly sure, but it is known that mechanical vibrations can either positively or negatively affect seeds.
Mm-hmm. And from our point of view, of course, this is absolutely crucial, because understanding the cause means that we can actually help to protect seeds that we are going to take into space in the future. So fascinating to find out the results, but also to try and understand the cause of it. Alana, I know that you were getting some great feedback from the students about why they thought the seeds may not have grown so well, the ones that have been flown to space. Can you run us through what some of those answers were?
Yeah, we had a lot that were on the money. So a lot of people wondered if the radiation was one of the biggest factors, and equally, yeah, the journey, so the vibration, and also, you know, things like the light levels, temperature, that kind of thing. But we did have a few people hypothesizing what would happen to the seeds when they were growing. You know, would the plants grow upside down because they got confused while being up there, or would they grow blue and things like that? So it was brilliant to hear all those different theories and ideas. And again, that's a part of science, isn't it? You put your hypothesis in there and work out, you know, what you think is going to happen, and then watch what happens at the end. So it was brilliant, really fun.
So there's a question that here that's come in from Zach from, again, Lamar de Carteret School, has asked what was the nutritional value of the plants grown in space the same as the ones that didn't go to space? And I don't know if that was part of the experiment.
It kind of. Some of our colleagues at Royal Holloway actually measured some of the chemical composition of the seedlings from seeds that went to space and the ones that stayed on Earth, and they didn't actually find any differences in the chemicals that they looked at. So what we presume is that probably the nutritional value is quite similar.
Right. That's interesting, and also good to know.
Yeah,
there's no point in growing food for us on a future mission if it's not going to have the right level of nutrients. And another great question from Jack Jones has asked, would there have been a difference if the seeds had been kept outside the space station? What do you think then?
Oh yeah, probably. I mean, the conditions outside the space station are much more harsh. I mean, you've got the hard vacuum, which can cause like really ultra drying. The seeds are already dry, but there's still some water bound to the seed. This could be evaporated into space, and even the oils in the seed could evaporate. And then there's also the intense radiation from the sun, which they're no longer shielded from, such as the ultraviolet. And this is really lethal to a lot of seeds in the outside in space. But if you protect them from the UV, it's quite amazing that some seeds can actually survive, and they've been brought to Earth, and they will still grow.
Yeah, absolutely. And you know, again, finding out where best to store them is going to be another crucial factor for the future. You mentioned about the radiation, of course. That's not just something we're concerned about with the seeds, but it's something that's very close to our hearts as astronauts. You know, we were told that on the space station, a day on the space station is the equivalent of having about 8 chest X-rays a day. That's the kind of exposure that we have as astronauts. So we're keen to try and improve the radiation shielding around our habitable volumes as well. Another good question from Sebastian Jennings was, would it have made a difference if a different type of seed had been flown, and why rocket? We spoke a little bit about rocket, but what other seeds might have fared well?
I'm not actually sure, but I do know that different species react differently to space flight. I think small seeds, such as one of the weedy species that is studied very commonly in science as a model species, Arabidopsis, is quite sensitive, for example, to the UV in space. Whereas other seeds have been sent to space and almost show like no effects, like tomato seeds. So I think really more work probably needs to be done to actually assess and compare different species in space. But it's definitely likely that they'll respond differently.
So that sounds like an opportunity for your next mission, Tim, for us to find a different species. So I think Alana and I had to have a conversation about that and come up with a new plan. I think with science, there's always the question we have to ask, so what? There's a great question from Kingfisher Hall Primary Academy, which is, has the experiment shown that we can grow food, vegetables and fruit in space in the future?
Well, not directly. I mean, there's a lot of other experiments going on in space that are actually looking at growing food in space and even simulating things like Mars gravity and things like this. What our results show is just a small part of the equation, which is that you can perhaps store seed on your journey to space and to Mars, for example. So, I mean, what our results say is that we should really consider to make sure that when you get there, you can still use the seeds. And this storage is actually really important here on Earth too, for farmers storing seeds for agriculture, and also for people who want to conserve wild species.
Right, well, we're nearly out of time, but a couple of things I just wanted to touch on quickly before we finish. So, Tim, your role in science experiments done in space. So, what do you think your role is? Are you the scientist or what?
Well, no, I mean, we're really the lab technician. We love to know as much as we can about the science because it makes it more interesting for us when we're on board the space station. It makes it interesting if we know what we're doing and why we're doing it. But actually, we're just implementing, the exact technique that the project leader of this science experiment wants to do. So we run the pieces of equipment. The experts are the scientists down on the ground.
Well, in contrast, then, Jake, what sort of thing do you do in a typical day? What's the most exciting part of your week, I suppose, is what I want to know.
I mean, the most exciting part of what I do is probably the experimental work, which is we're asking new questions and trying to answer unanswered questions. But my days can be quite varied. Some days I'm doing experiments in a lab. Some days I'm at the desk just analyzing data and reading. And other days I'm actually mixing up soil to grow plants in a glass house. But yeah, I mean, I trade a couple of days to be an astronaut for sure.
Brilliant. Right. Okay. I think we better move on quickly. And just, Tim, one last question on all this. Do you think we'll one day grow food in space? There's lots of questions come in about this, so I won't list them. Absolutely.
I mean, the problem is that, Earth's gravity is actually quite difficult to escape. We know that when we try and launch rockets and get into orbit, it costs a lot of money. It takes fuel and it takes energy to escape Earth's gravity well. So if you've got to take tons and tons of food with you on a 3-year mission to Mars, then you're either not going to be able to achieve the mission, or you're not going to be able to do anything when you get there because you haven't really been able to take anything else with you. So we need to be able to cut down the weight of the food that we take, and we need to be able to grow our own food on the journey and grow our own food when we get to another planet. So this is all vital research for being able to explore further into the solar system. But just to touch on what Jake said, everything we do in space has benefits for people back down here on Earth. And by understanding more about how we can grow food in hostile environments means that we can start to grow food here on planet Earth when there is drought, in hostile environments, when the soil might not be so good. We've got 7 billion people to feed at the moment. That's only going to increase over the next 50 to 100 years, up to about 11 billion people. We need to really improve our food growing processes on Earth. So what we learn in space gets applied back here on the ground.
So it's not just about the Martian and growing potatoes in, well, let's not go there, shall we? Hey, if you've seen the film, you know what I'm referring to. Good film there. Right, so I think we better finish there. But are there any things we can do at home? Can we have Alana back on screen? Alana, I'd like to know if there's anything that people back home can do if they're interested in getting more involved in this sort of stuff.
Yeah, I mean, obviously, we can't easily get seeds that have been up to space. It's not something to buy from the shop, but something you can try is growing things in different environments. It's quite a common experiment for young people, and it's very exciting to look at the differences. So you could grow rocket again or cress or something like that, and maybe put one on the windowsill, one in a cupboard, somewhere cold, somewhere warm, and just look at the differences in how they grow, and actually maybe have a think about what kinds of things we're lacking in space, and then how we get around that. Light is difficult, temperature is difficult, so all those things. So you can do your own experiments at home that really do apply to what's being done up there.
And there's advice on your website, the Campaign for School Gardening?
Yes, so if you head over to the Campaign for School Gardening website, and we've got loads of activities, and I mean, like Tim said, growing food is a really important skill for many people to learn. So we've got a lot of information on our website about that too, if that's something you're interested in.
Right. And then when it comes to eating it, we've got Mission X, Train Like an Astronaut. So this is based on the training that astronauts go through and the kind of food that astronauts eat. So that's really good fun for 8 to 12-year-olds. Anybody at home can take part in that these days. So that's really worth having a look at. The details will be next to the stream online if you want to look. And then finally, I'm sorry if we didn't get to one of your questions. We had so many really good questions in. We're going to keep a list of them, so we'll try and keep coming back to them over the following weeks. But we've got a really good question here from James at St Wilfrid's Catholic Primary School in Hertford in Northwich. And he says, is climate change affecting space? Well, we don't think that it's affecting space, but we can certainly detect it from space. And that's what we're going to be talking about next time. So 2 weeks today, we're going to have the fourth of this series. We'll have Dr. Anna Hogg from the University of Leeds talking about climate change particularly, but viewing our planet from space. So do join us then. Thanks for watching, and thank you very much, Tim, for being with us. And thanks to Anna and to Jake. See you next time.
Thanks very much, everybody. Thanks, Anna. Thanks, Jake.
Bye.
Bye. Thank you.